As you mentioned in class, we're going to have to deal with both the algebraic, well, not both, but all the algebraic, the graphical, and the numeric representations of a function. So here's our numeric, right? We have a table. Um, what we should do on these is slow things down. So very first question, we are looking at an h of x, which is clearly a composition of functions, right? We can see our f of x function inside of or composed with our g of x function. So there's that g, our outside function. Ah, I meant to change colors. Let's see if I can do that. There she is. Okay. So first thing I would do as a student approaching this question is just slowly write down what I'm working with. So we know we need to take a derivative because we have an h prime of -1. So h prime of x is g prime of f of x times f prime of x. This is just our chain rule written with our f and g switched from where we normally write them in our class when we do our little column response at the beginning. And then I'm going to go ahead, we want to find h prime of -1. So we're going to go ahead and replace all of our x's with -1s. And right now we're already ready to go find some of these -1s. We have an f of -1, and we also want to find an f prime of -1. So let's go find both of those. So -1, here's my f prime, and here is my function's value. It's 0. Then we could just take a moment to write those down. F of -1 was 0, f prime of -1 was 2, and we can bring back everything else that was in this. We need a g prime of 0 now, so let's get a new color highlighter, and we need g prime of 0. So in the 0, we're looking for that derivative. There it is. So this is all equal to 4 times 2, which is 8. But you see, if you move slowly through these problems, there's just less chance to make errors. Easier for me to see your work to give you partial credit. Whereas if you try to do this in your head, very likely that I would not be able to follow what you did and give you any points if this was off. All right. So let's see the next one. Looking at number 5, we can see, hopefully, what appears to be, or what is, hold on, there we go, a product of two different functions. One of those functions is defined as g of x, the function up in our table, and then we also have this x cubed, this separate function that's algebraically defined. So this is a nice little mix and match of our table with some algebraic stuff. Again, we're asked to find k prime of -1. So I would move slowly by finding my k prime of x, finding that derivative of our k function, which of course needs a product rule. So derivative of the first times the second plus the derivative of the second times the first. Right, and I'll go ahead and highlight these so we can see there's our second function. There it is as a derivative. There's our first function as a derivative and not. Okay, so now we can go ahead and find k prime of -1. So here we'll have 3 times -1 squared times g of -1 plus g prime of -1 times -1 cubed. So over here, I'm just going to clean it up a little bit. -1 squared is just +1, so this is 3 g of -1. And then here, -1 squared cubed is negative. So let's make this a negative g prime of -1. And you could have plugged in. There's no reason not to plug in early. I just figured let's clean some stuff up before we get started. All right, so now we're ready to use our highlighter. We need a g of -1, and we need a, I'm trying to use colors I haven't used yet, g prime of -1. Okay, so we come back over here. I broke something. I don't even know what I did. There it is. Oof. All right, we need our g prime of -1. It's 1. And we also need our g of -1, which is -5. So let's go ahead and bring these in. So we had a -5 and a 1. Bring everything else down. Looks like we have a -15 minus 1, which is a -16. All right, so that's 4 and 5. We'll take a pause here and we will do the rest in a separate video.